Need a dead simple way to create an AI-callable server that responds to requests instantly? You'll see how to build a complete FastMCP server in under 15 lines, including a greeting tool that AI models can invoke directly, plus how to run it with different transports like STDIO or HTTP.
Hash my server, Pi. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals my server. @MCP, tool. Def greet name, SDR. Agree to user by name. Return hello, name. If name equals main. Hash this runs the server, defaulting to STDIO transport. MCP, run. Hash to use a different transport, e.g. HTTP. Hash MCP, run transport equals HTTP, host equals 127.0.0.1, port equals 9000.
This demonstrates the server as a container pattern for building modular RPC services. The FastMCP class acts as a central registry that transforms ordinary Python functions into callable tools through declarative decorators, while handling all transport, serialization, and discovery automatically. What distinguishes this approach is its complete separation between your business logic and the RPC infrastructure. Your functions remain pure Python with no framework-specific dependencies. The pattern works by treating the server instance as a composition root that aggregates components at runtime. Decorators like @MCP tool serve as lightweight registration mechanisms, while the framework dynamically generates API schemas from type hints and docstrings. This design enables a clean architecture where tools are first-class citizens, discoverable by clients without manual routing or documentation. Just add functions to the container, and they become part of the exposed interface. This approach solves the dual problems of RPC boilerplate and tight coupling between logic and transport. You avoid writing repetitive root handlers, validation layers, or serialization code, while gaining automatic client compatibility through standardized schemas. It's particularly valuable for AI integrations, internal microservices, or any scenario where you need to expose backend capabilities without building a custom API layer, though the trade-off is framework-specific decorators in your codebase. Let's break it down.
Hash my server, Pi.
This declares the module name, establishing my server, Pi, as the entry point for the FastMCP server implementation. The file name becomes the import reference for tool registration and server execution, following Python's module system conventions.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for building AI-callable tool servers. It transforms regular Python functions into structured tools that AI models can invoke, complete with type hints and docstrings as the schema.
MCP equals FastMCP. Name equals my server.
This instantiates the core FastMCP server with the identifier myServer. The name parameter distinguishes this server instance in distributed systems, enabling tool discovery and routing across multiple MCP services.
@MCP, tool. Def greet name, SDR. Agree to user by name. Return hello, name.
The @MCP tool decorator registers this function as an AI-callable tool. FastMCP uses the type hints and docstring to auto-generate the tools schema, ensuring the AI understands the input-output contract. This is the core pattern for exposing Python functions to AI models.
If name equals main. Hash this runs the server, defaulting to STDIO transport. MCP, run.
This is the standard Python entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module. Without it, importing this file would accidentally start the server.
Hash to use a different transport, e.g., HTTP. FastMCP. Run transport equals HTTP. Host equals 127.0.0.1. Port equals 9000.
This commented line demonstrates FastMCP's transport flexibility. By default, it uses STDIO, but you can switch to HTTP or other protocols by specifying the transport parameter. The host and port arguments configure the network binding for HTTP mode. FastMCP Server Foundation. This simple server pattern with at MCP, tool, and transport options forms the backbone of all FastMCP deployments, from local CLI tools to cloud services. The default STDIO transport creates a new server process for each client session, while HTTP transport maintains a persistent server for multiple connections. Always specify the transport explicitly in production to avoid unexpected behavior.
The server that never stays running handles every request